Hi! In this video, I'm going to share with you 7 ways to reduce amount of initially loaded JavaScript for modern Angular applications. This is crucial for so many apps because the more JavaScript your application has to load before rendering the very first component, the longer your users stare at the blank screen, and that directly impacts user experience and potential bottom line. My name is Dmytro and I help people to become advanced Angular developers. So let's get started and dive into the topic. Before you start any optimization, you need to know your current bundle size and structure. So the first step is to open your terminal and perform the production application build using the stats.json flag. It is important to build an application with a production configuration to enable optimizations like tree shaking, code minification, and others to eventually get accurate numbers. From the command output, we can learn the total size of JavaScript that will be eagerly loaded, which is exactly the metric we have to focus on. Another important artifact we get from this command is a stats.json file, which contains information about our bundle structure. You simply have to drag and drop this file into the online tool, the link to which I will leave in the video description. Once you do that, you will get a nice visualization that will drastically simplify the debugging process for you. Now we have to learn how to read and understand this bundle visualization. Here, every high-level rectangle represents a particular chunk of my application, which is also divided into smaller rectangles that represents code from specific libraries and modules. For example, my main bundle consists of a node module that contains the code of all libraries I use in this project. And next to it, there is another rectangle that represents the application source code, like components, services, directives, and other building blocks that I create for my application. The node chunk is then split into even smaller rectangles that represent code from specific libraries, like Angular, Lodash, RxJS, and others. Then you can easily dive into a particular library and see exactly which modules from it are included in your final application bundle. Usually, the first thing I immediately check is the ratio of CommonJS to ESM modules in my bundle. Ideally, the CommonJS code should be 0%. If it exceeds, this is a red flag for me. The problem with CommonJS modules is that due to their dynamic nature, tree shaking optimization is quite problematic for this module system. As a result, they can include a lot of code that takes up space in the bundle but is never called. To reveal parts of your bundle where CommonJS modules are used, simply click this ratio bar, and the corresponding libraries or modules will be highlighted with a blue background. In my case, it is a Lodash library, which takes up quite a big part of my main bundle. Usually, you have a few options in this situation. You can click on the library and see how extensively it is being used and check how complex a problem it solves. Sometimes it is worth spending a few minutes or hours to implement your own solution and completely get rid of the library. If that's not an option, you can always find ESM-based alternatives or sometimes even a drop-in replacement. For example, Lodash has a drop-in ESM-based replacement distributed as a separate NPM package, which is called Lodash ES. So in my case, I can simply install this package with the corresponding typings into my project. And then, everywhere where I imported functions from Lodash, I have to adjust the path and replace it with the new library. After that, you can try to rebuild the application and see that this time the total bundle size was significantly reduced because now my bundle includes only the Lodash code that I actually use, making the part of this library in my main bundle about 5 times less than before. Looking at our current bundle visualization, there is a polyfills chunk almost entirely occupied by Zone.js. Zone.js is a library that is required to be eagerly loaded along with your application's main bundle because it plays a significant role in Angular's change detection process. If you want to learn more in depth about it and change detection overall, I have a dedicated video that you can check out later. However, starting from Angular 20, change detection works stably without Zone.js, so we can get rid of it and save another dozen kilobytes. The migration to Zoneless is simple yet challenging. The most challenging, though not required but highly recommended part is migrating all your components to the on-push change detection strategy if you are not using it by default. If you are not confident in this topic yet, you can learn more in my other free video on YouTube. To make your migration smoother, more confident, and safer, I also recommend that you cover your code with tests. You can learn how to write reliable and useful tests from my course, the link to which I left in the video description, along with the discounts limited to the first 20 students. Once you have migrated to the on-push change detection strategy and made sure that everything works fine, then going zoneless is quite easy in most cases. For that, simply jump to the Angular JSON file and remove all lines containing the zone.js string. After that, switch to app.config.ts or app.module.ts file, depending on whether you are using Standalone API or not, and replace the zone change detection provider with the zoneless one. As easy as that. After saving this change and rebuilding the application, you can enjoy a reduced total bundle size as well as improved performance and developer experience. Because Zoneless, it is not only about bundle size. If you take a look at our current bundle visualization once again, you might notice that a pretty solid part of our bundle is taken up by the Angular Animations package. Considering that I use Angular Animations only in one place in my application to extend and collapse the weather widget content, I would say that 61 kilobyte is a pretty solid price for that. But fortunately, there are a couple of solutions here. If your application uses Angular version between 17 and 20, the best solution for you would be to lazy load animations. And this is quite easy to do. Just go to your app.config.ts or app module file and import an async animation provider from the new Angular animation package path. After that, add this provider to the corresponding providers array either in the ng module or the corresponding place inside app.config.ts file if you use Standalone API. After that, you can open your terminal and build the application once again, and if everything is okay, you should see a new lazy chunk that contains Angular animations and the total loading size should be significantly reduced. However, if you use Angular version 20.2 or newer, you can benefit from migrating from the deprecated Angular animation package to native CSS animations. Because migrating to CSS animations is not the topic of this video, I will implement this transition in the background and simply walk you through the most important changes. But if you would like to see a dedicated tutorial from me where I show how to migrate from legacy Angular animations to CSS animations, please let me know in the comments. But anyway, The general idea of this new approach is that you describe animations by using CSS classes and animation keyframes. And then you use those CSS classes along with the new constructs available starting from Angular 20.2, and they are called animation enter and animation leave. In such a way, you can achieve the same and even more performant animations because native CSS animations can use hardware acceleration that can make them smooth even on weak devices. And we can also significantly reduce our main bundle size once again. We have already discussed tree shaking in the context of CommonJS module system. However, there are other techniques that allow you to tree shake even more code from your bundle. One such technique is to migrate to the Standalone API if you haven't done so already. In modern Angular, this is the recommended and default way to build applications, and this API is more tree shakeable compared to the approach based on ng modules. Again, because this is not the main topic of this video and because I have already partially covered migration to the Standalone API in one of my previous videos, I will skip the entire migration process and simply show you the impact of this change on the bundle size. So once I have successfully migrated to the Standalone API, and if I rebuild my application, you can see a slight but still positive improvement in our bundle size. Another approach to improve the tree shakeability of your code is to prefer using pure functions instead of class methods whenever possible. Quite often, I see people create something like a utility service and fill it with dozens, sometimes even hundreds of small and stateless utility methods. At first, the idea to group related methods under a class sounds totally reasonable, but the problem is that class methods, they are not tree shakeable, which might negatively impact the bundle size of applications that share such a service. In my case, if I split my utility service into a set of utility functions and rebuild my application once again, you can see another improvement in my bundle size because I used only one or two of those service methods. And please don't underestimate this pattern. Once I consulted a company where they had a utility service that contained about 10,000 lines of code or more, and this service was shared across dozens of their applications within NX monorepo. And those applications used one or maybe 10 or a couple of dozens methods from that service, and because of that, each of that applications got a necessary 1.5 megabytes to their bundle size, which is crazy. Up until now, we've gone from 550 down to 373 kilobytes, which is absolutely great result. And we didn't even apply the most powerful technique, which is lazy loading, and this is where Angular particularly shines. For example, let's take a look at our current bundle visualization and focus on our application code by clicking the corresponding rectangle. A solid part of my code, it is about 55 kilobytes, is taken up by components and services under the data grid widget folder, which serves the entire feature represented by a very complex table. Also, this table isn't visible in the user's initial viewport, so it would make sense to load and activate this component lazily. And to offload such a heavy component from the main bundle, in Angular you can use the defer block, which should wrap the component you want to lazy load, just like that. And if you want, you can additionally specify rules for when exactly it should be loaded. For example, right now it will be loaded when the user scrolls to this table. But obviously, the defer block has much richer functionality, and you can explore more features in my other video dedicated specifically to this topic. But anyway, once we try to rebuild our application now, you can see another significant improvement that drops the amount of initially loading JavaScript even further down to 295 kilobytes. And of course, we could go even further and apply the best known technique known as root level lazy loading, which allows you to offload the code of components associated with a particular root. So just like that, by using load component property, you can reference the component you want to lazy load, and this is everything you would need to do. This simple but highly efficient technique allows us to reduce the total initial metric even further, cutting it in half compared to what we had at the beginning of this video. When you start using lazy loading, it's tempting to think like, okay, let's lazy load everything we can. This is partially true. However, there is one simple rule you have to follow. Do not lazy load things that's supposed to appear on your page instantly. For example, if the home page, it is a page where most of your users start to interact with your application, do not lazy load this page and include it into the main bundle. The same applies to defer blocks. So try to avoid using them for components that appear on the initial screen, because otherwise you might get user experience that is opposite to what you are looking for. Alright, my friends, that was 7 ways to reduce the amount of initially loaded JavaScript for your Angular applications. Of course, I didn't mention all of them. For example, barrel files could cause unnecessary code retention in your application bundles. Or you could use a lightweight injection token pattern, which might be especially useful for library authors that can also make your library more tree shakeable. And I covered this pattern in my other free video on YouTube that you can check out right now and learn more about it. And probably I forgot something else, but I'm pretty sure you will be happy to correct me in the comment section under this video. Otherwise, thanks for watching. Check out my Angular video courses, join our Discord community, and I wish you a productive week ahead, guys. Stay safe and see you in the next video.